Greetings everybody, and welcome to a little bit of video on descriptive statistics. I know that for many of you, statistics can be a little bit intimidating, and you may even skip that section of a research article. And we certainly don't want you to have to worry about, some of the more complex statistics like, analysis of variance or some of these things. But I think it is important for you to have some sense about how to at least interpret descriptive statistics, because those are the most common ones you're going to see and really are the most meaningful ones to get a sense about the data. So first of all, just a brief description here, right? Descriptive statistics are used to describe the basic features of the data in a study. They provide simple summaries about the sample and their measures. And so you'll see some differences of opinion on this in different books about the different types of descriptive statistics. But I'm going to try and give you an overview of the three kind of broad categories I think that are generally regarded by most researchers to be the different type of descriptive statistics. So it's often broken into three categories. One, the distribution. And this just talks about the summary of the frequency of individual values or range of values for a variable or set of data, and we'll give you an example about that in just a second. And then there's central tendency, which is the mean, median, and mode, right? It's the central tendency of a distribution is an estimate of the center of the distribution of values. And you probably are familiar with those. At least you're familiar with mean, at least for sure. You may be vaguely familiar with median and mode, but we'll talk about those as well. And then last is dispersion. It refers to the spread of values around those central tendency measures. How spread out is the data. And combined, when you take a look at the frequency of the data, the central tendency of the data, and then how dispersed the data is, this gives you a good representation about your data and gives you a good sense about what some of the characteristics of the data are, and allows you to be able to make more accurate conclusions. So let's take a look at an example of each one of these on the next slides. So distribution. Again, I think so one of the most common ways to do this is with just a frequency distribution. And if you really wanted to take this the extra mile, you would actually list every single piece of data. Now, if you have a fairly large study, that's going to be pretty tedious. So we want to see if we can come up with a better way to summarize that particular frequency. So I'm going to take a look at Table 1 here shows an age frequency distribution with 5 categories of ages defined. So you can see it's telling us the frequency of individuals in each of these categories. So for example, I see that 45% are in the category 46 to 55, only 6% are at ages 66 and over. So again, frequency distribution can be represented in the table like this, and the same distribution can be represented in a graph. So if we take a look at that same 46 to 55 that we see in the table on the left, that's 45%. And if we look at the frequency distribution bar graph on the right, and 46 to 55, and we see where that goes to the top there, that's it, right? About 45%. So both of these are representing the same frequency, just in a different way. And I would encourage you, if you have a case for using this in a study that you're doing and you're reporting the data, it's often nice to do both ways, to have a table and then also have a bar chart. And the reason for that is some people can interpret the table more easily. Even I would think probably some of you may find the table easier to interpret. Others may find that the bar graph's much easier. And so when you have both types of frequency distributions represented in your data that you report in a study, it really allows the reader to get a more accurate understanding of what's happening in your particular study. So that's the distribution. Central tendency again measures an estimate of the center of a distribution of values, and there's 3 types. We mentioned those already. So the mean is just the average, and it's probably the most common one, right? So to compute this, we just add up all the values and we divide by the number of values. This is going to give us the average. So an average is nice, but it can miss some important details that we might want to know. So if we have a relatively small number of data points in a study, and we could have a number of them at the high level and a number of them at the low level, and none of them kind of in the middle, and then if we take the mean, it would kind of give us the sense that most of the things are in this middle level. So that's one of the downsides of a mean or an average, is it may not take into account some of those extreme data points really accurately. So another way to take a look at center tendency is the median. And this is a score found at the exact middle of a set of values. So the best way to do this is to list all the scores in numerical value and then locate the score in the center of the sample. This gives you a pretty accurate representation of what is the middle of the sample, and the mean might not necessarily do that. So it's nice to have the mean and the median computed. And then the mode is simply the most frequently occurring value in a set of scores. So in the set of scores 2, 7, 7, 8, 14, 15, right? The number that occurred twice there would be our mode. So combined with distribution and frequency distribution, these measures of central tendency give us a richer description of what may be happening with our data. And last but not least is dispersion, right? It's the spread of values around the central tendency. So it doesn't tell us how frequently things are happening, but how spread out they are. And there's two common measures of dispersion. One is simply the range, and this is the highest value minus the lowest value, but this can really misrepresent the spread, particularly if we have outliers in our data. So if our mean is 47, but our high value is 89 and our low value is 10, we could get a range of 79, when really most of the numbers are bunched around the mean and we just have these two kind of wide values. So the range is nice to compute, but really the more valuable one, and unfortunately the more difficult one to compute, is a standard deviation. In a way, the standard deviation gives us an average of the dispersion around the mean. And it's a much more complex value to calculate. In fact, I would recommend not trying to do it on your own and to use a computer program to do it. You could also do it on more sophisticated graphing calculators. But again, because it's giving us an average of these spread of values around the mean, it's probably going to give us something more accurate than simply a range. And it'll give us an idea about the number of values that occur within a certain distribution or dispersion around what our mean would be. So these are our most common measures of descriptive statistics. I know these are described in your book, and you've got a little bit of extra information on the course site. If you have any questions about these or need some additional examples, please don't hesitate to reach out. As always, have a wonderful day.